So in Rosen section 1.6.3, he discusses basic inference rules. And recall that these basic inference rules are going to be short, valid arguments. You can kind of think of them as like helper functions that will allow us to build more complicated arguments. So in Rosen section 1.6.3, there is a table. And this table 1 is going to contain a bunch of basic inference rules, these short, valid arguments. And this table 1 right here has a bunch of these, and they come with a ton of fancy names. And so most of these names people don't actually memorize. And so in fact, table 1, all of these basic inference rules, I don't want you to memorize them, I want you to understand them. And so to help you understand the various basic inference rules that are contained in table 1, let's go ahead and revisit the example that we looked at in the previous video. And if you recall, we had hypotheses P and P implies Q, and our conclusion was Q right here. This comes with a fancy name, modus ponens. You don't need to memorize that. And in fact, we don't need to memorize this right here. We need to understand it. And so in the last video, what we did is we wrote down a truth table for these various things, and we sort of looked at different rows of the truth table, and we tried to reason out and suss out whether or not this condition right here is true. So what I want to do here is show you an alternate way that we can take this definition of a valid argument, because remember, a basic inference rule is just a short valid argument, and show you a way that you can verify that they are true. That way, in case you ever run into an argument and you forget if it was on table 1 or not, you can then quickly reprove or verify to see if it is a valid argument or an invalid argument. So let's go ahead and think again about this definition of a valid argument right here. So it's valid if when setting all the propositions true, okay, so I want them all to be true, this implies that the claim is true. So what I could do is translate that into the following. This modus ponens right here is a valid argument if setting all the propositions true implies the claim or conclusion is true. So let's take my propositions. P, I want that to be true. And I want P implies Q to be true. And I want this to imply my conclusion right here. And I want this to always be the case. I want this to be a true statement no matter the truth values of P and Q. Oh, well, that's nothing more than showing that this thing right here is a tautology. We've already discussed tautologies, so we know how to see whether or not this is a tautology. So I've taken all of my hypotheses right here, I use an and to connect them up, and I want to show that it implies my conclusion right here. And I want to show that's true in every single case, so I want to show that this thing is a tautology. And we can simply use a truth table to verify that this indeed is a tautology. So let's go ahead and do that. So let's go ahead and try to fill in this truth table right here and see whether or not this proposition right here is actually a tautology. Thankfully, this is an implication, and we know that this implication right here, the only time it's going to be false is when the hypothesis right here is true and the conclusion is false. So we automatically know that this entry right here is true because my conclusion is true, and I know that this entry right here is true because my conclusion here is also true. Over here, well, if P is false, then this hypothesis right here is going to be false. So I automatically know that this hypothesis is false, and so it doesn't matter what the conclusion is, this entry is also going to be true. So the only one that's going to take a little bit of work is trying to figure out this particular row. So P is true, okay, excellent. And then we have a true implies false. Ah, that's a false statement. So we have true and false, that's a false right there. Well, false implies anything. Oh, that's a true statement. Oh, fantastic. So we have been able to show that this thing right here is indeed a tautology. So if ever we were presented with an argument here, like this modus ponens, and we needed to see if it's a valid argument or not, we don't have to memorize this. We could simply, using the definition of an argument right here, reconstruct and reprove whether or not it's a valid argument. That's why I'm saying that you don't have to memorize it, you simply need to understand it. If we can quickly construct these truth tables, we can quickly verify whether or not, when presented with an argument like modus ponens, to see if it's valid or not.